All right, now's your chance to redeem yourself. A regular polygon. What's a regular polygon? That if you look out the window of your car almost every single day, you'd probably see one. What would that be? An octagon, which is a stop sign, right? A regular octagon is a stop sign, and my guess is that every day you ride in a car, you probably see a stop sign somewhere. All right, so if your mission was to find the area of a stop sign, what would you do? Well, you don't know right now, okay? You don't know, but we're going to hopefully figure that out, all right? So the area of a regular polygon. We got to talk about a couple words first before we even consider finding the area, all right? There's 3 words that we're going to talk about, and I'll tell you what, let's draw one, and then we'll put those words in the picture. All right, let's see. Why is that not? There it goes. Polygon. And since we're talking stop sign, let's put a stop sign. There you go. There's a stop sign. Well, it may not be a stop sign, but it is a what? Be more specific. Be more specific. Thank you. It's a regular octagon. It's not just any old octagon. It's a regular octagon. All right, so there's 3 words that we got to talk about before we even discuss the area of this. Okay, one is the radius. You've probably used radius before, but you used radius on a what? On a circle, okay? You've probably talked about radius, pi r squared. You've heard that before. But that was always a circle. Well, a regular octagon has a radius as well. All right, and I'm going to write these down. It's in my notes, so we might as well write it down. Okay, it's the segment that joins, Now, on a circle, what did it join? The middle? I think we've talked about that word before because we talked about the area of a circle. What do I call that? What do I call the middle of the circle? I don't call it the middle. It starts with a C. The center of the circle, right. But this has a center as well. Okay, it's not a circle. Okay, so it's the segment that joins the center and the vertex of the polygon. And the vertex, oops, forgot the R, vertex of the polygon. All right, so that's the radius. Well, let's draw one. Actually, I got to do this first. See, on this program, if I select it, it actually tells me where the center is, doesn't it? Isn't that nice? So it's about right there. So what's the radius of this? It's from where to where? From the center to the vertex. Does it matter what vertex we pick? Nope. That would be it. Look, as long as this is a regular polygon, okay, that would be the same as that, that. Okay, everybody see that? I can start from the center, go to any vertex on a regular polygon, and I'm going to use that one right there for a reason. Everybody okay with that? So what do we call this? The what? The radius. Okay, so that is the radius. All right, so that's our first word. How many words did I say we're going to do before we talk about the area of it? 3. So the second one is this. It's actually 2 words, but it's one idea. It's the central angle. All right, central angle. Let me read that, or let's write that down. It's the angle that's formed. The angle, they don't say that, so they just say formed. By 2 radii. By 2. What's up with radii? What's that word? No, it's not singular. Radius is singular. It's plural. Okay? From the radii, drawn to consecutive vertices. Consecutive. I'm not going to make you memorize this or write it down on a test or a quiz or anything like that, but it's good to see it in writing. You can always flip back to it and go, oh, what's the central angle again? Flip back in your notes, boom, you see it. You read it, and you're like, okay, now I kind of get it. All right, so let's just keep this in red, at least this next part. So it says the angle formed by two radii drawn to consecutive vertices. Well, here's one radius, correct? It's going to this vertex. What if I drew it from that center and I drew it to one that's right next to it? That's consecutive, right? This vertex and this vertex are consecutive vertices. Or I could have drawn it here, couldn't I? Would that right there be the central angle? No, because it's got one in between. It's got a vertex in between, right? But if I go from one vertex, the center to one vertex, the center to the vertex right next to it, that would be considered a central angle. So this angle right here, I'll put a little arrow because I can't fill that in. I can't write that in there. It's called the central angle. It's very important. We're going to use central angle a lot, not just on this lesson, but for other things as well, okay? Everybody got that? That's a central angle. We're going to talk about when we do a chapter. I think the next chapter is circles. Look, anybody got their book open? Flip to chapter 8. What's chapter 8? I think it's circles. Is it? Okay. So we'll talk about the central angle with circles as well. And we'll talk about the radius. Okay. We probably won't talk about this next word. But this next word is a word, like radius, you already knew that. You know what an angle is. You kind of know what central means, right? Because, look, it's an angle with what as the vertex? The center is the vertex, isn't it? Okay, do you understand why we call it the central angle? Right? So we're not talking about this angle down here. We're not talking about this angle right here. We're not talking about this angle right over here. We're talking about the one that joins the center. Got it? Central angle. Good? All right, one more. Well, one more word, and then we can start talking about the area of it. This is a little different. It's called the apothem. You probably have not heard that before. Am I right? Yeah. So this is kind of a new word for you. But you have kind of done something. We didn't call it the apothem, but it is something that we've kind of talked about before. You know what perpendicular is, right? So it's the perpendicular segment that joins the the center. So it starts at the center again, just kind of like the central angle did. That joins the center with a side of the polygon. With a side of the polygon. I'm going to do this in a different color because we've got too much red over here. So let's go with that yellow. All right. So what is it? It's a perpendicular segment that joins the center. So where am I going to start? At the center. Very good. Okay, the perpendicular segment that joins the center with a side of the polygon. All right. So I could go to here, couldn't I? Right? I could go to there if it's perpendicular, right? I can't go to there. That's not perpendicular. You follow me? I'm not going to a vertex. What am I doing? Going to perpendicular to any of those sides. That would be an apothem. Now, I'm going to purposely go to this one. All right? So if this is perpendicular, then what's that yellow thing right there? What do we call that? The apothem. Say it with me. 1, 2, 3. Apothem. All right. And give me a sec. Oh, okay. They do some stuff first before they give you a way to figure out the area. You're leaving again? How long is this going to happen? Rest of the year? Is it really? Once a week? Thought you did it twice last week. All right, once a week. I'm good with once a week. All right. All right, let's do an example just with the stuff that we're doing here. It's going to kind of lead you up to the area thing. The area, it's actually a very simple equation, but it's something we haven't done, and there's some things you got to figure out. Sometimes they don't always tell you all the information. Like the area of a rectangle. They usually give you the base, they give you the height, boom, you find the area, multiply them together, right? And And then they switch it up. Sometimes they give you the area, they give you the base, you got to find the height. No biggie. This is a little different. It's a little bit more involved than what we've done before. So let's go back to that octagon again. I'm just going to grab this because I'm going to do some other stuff with this. So we're going to do a regular octagon again. I'll make this one just a little bit bigger so we can write on it. There we go. Big old regular octagon. And let's find the center. Center's right there. So I'm going to put a point right there. And we'll call that point P. We'll call this one R. We'll call this one Q. And let's see what they asked you to find. They say find the measure of the central angle. They don't give you any numbers except that you got 8 sides. That's all they tell you. All right? You got to find the central angle. So watch what we're going to do here. Let me see what I want to do first. Yeah. So let's find the central angle first. I was thinking about maybe changing the order of what we do, but I think this is perfect. Right, I could have drawn it anywhere, but since I already marked this R and Q, that's where I'm going to mark this. So what I want you to do is I want you to find that angle right there. And that's all I give you. That's it. I don't tell you any other angles. I don't tell you any lengths of the sides. That's all I tell you. Would you be able to find that angle? Watch this. Let's do this, just to help you out a little bit. All right? What if I drew one to here, one to here? Get the idea? There we go. Look at that. Everybody with me? This is just kind of a hint, just so you can figure it out. Again, I want to find this angle right here, angle P. See that one? That white one with that arc? That's what I want to find. Well, tell me something about this angle that I'm trying to find, and this one, this one, this one, this one, this one, this one, this one. What are they? They're all the same. Exactly right. They're all the same. So go ahead, Zvinka. Did you figure it out? You got it right. You're exactly right. Because everybody watch. If I went from here all the way around to where I started, right there, how many degrees is that? 360, because we went all the way around. It's a circle, right? Basically. Right? So if I go all the way around to where I started, you know already that's 360. So if each of these angles, right, are all equal to each other, which they are since it's a regular octagon, if all 8 of those are equal, how do I find just one of them? I go 360 what? Divided by 8. And that is 45 degrees. All right, so this angle right here, that white angle, I'll change it back to white again. That white angle is what? 45 degrees. That's the first question they ask. Find angle P. Everybody got that? That's not too hard, is it? Again, that only works with the central angles. Remember, look, that whole thing would be a circle. I take 360, which is how many degrees a circle is, and divide it by how many angles I have, since they're all exactly the same. And so that would give you 45 degrees. We good? Now what I want to do is I want to find these 2 angles down here. I'll keep it in white. So watch. See this angle right there? Now, what's going to happen? This side and this side are both the radius, correct? So if this angle's got 2 arcs, then this angle right here has got 2 arcs, because it's a isosceles triangle. You with me? All right. So I want to find, they call them the base angles. We haven't used that word for this yet, but I want to find each base angle. Base angle. So let's take a look at this. This white one right here with the 45 and the 2 and the double arcs. They are, look, that and that are equal. So that must mean this angle and this angle are equal. These are called my base angles. This angle that's double marked, right? And this double arc right here, those are called base angles. right? Because if you looked at this as a triangle, you could consider this to be the triangle, right? Or the base of the triangle, I'm sorry. The base of the triangle. So these are the angles that connect the base of that triangle, right? So forget everything else. Just look at this triangle right here. Everybody see that? All right, so those are considered to be the base angles. So now you know what the base angles are. How do you figure them out? How do you know what the value of those base angles are? Go ahead, Denise. Yeah, you can, yeah, 45 is definitely going to be helping us here. There you go. You got it, okay? So I want to find what's left over. I only know one angle. It's 45. But what I can do is I can go 180 minus 45. What's that, 135? So that must mean that this angle and this angle, are they both 135? No. What do? They add up to be 135, right? And if they're both exactly the same, how can I find them both? I can take 135 and do what to it? Divide it by 2. I'll do the math for you. That's 67.5 degrees. So the question said, find each base angle. So what is each base angle? 67.5. Natalie, you're not going to learn anything like that. Just trying to help you out. I know you hear me. Come on, get your head up. They have a theorem. We already did this. With this 45 right here, it says, what if you had a regular polygon with n number of sides? So if you had n number of sides and it's a regular, I'll just put this, regular polygon. They give you a theorem. We kind of already figured it out. Look, if you have a certain number of sides, how do you find the central angle? You just take what? 360 divided by what? How many sides I have, which is n. If I have a regular polygon with n number of sides, that's going to give me the central angle. Everybody got that? So they make a theorem out of it. We could have figured that out even without a theorem. We kind of did figure it out, didn't we? Without that theorem. Okay, you saw that it made a circle. Divide by how many angles you have. How many angles you're going to have? The same as the number of sides that you had, right? So n represents the number of sides, 360 divided by that. That gives you that central angle. Make sense? All right. All that to get to what we're going to do right now. And what was our goal at the beginning? To find the what? Find the area, okay? So I'm not going to do the octagon because that's not what our example is. Maybe we'll come back and do an octagon. Actually, yes, we do. We do an octagon. Tell you what, let's just put that on here. I did a hexagon for some reason on this, but we can stick with the octagon. It's perfectly fine. So now we know all that stuff, all right? So I'm just going to give it to you. I'm just going to give you what the area of a regular. Remember, this only works when they're regular polygons. Again, for the 54th time, what's true about a regular polygon? All the what? All the sides are equal and all the angles are equal, okay? So if I have a regular polygon, this is how we find the area of it. Remember, we found areas of other things. Area of a rectangle is base times height. Area of a triangle, 1/2 the base times the height. Okay, area of a trapezoid. Remember that? 1/2 the two bases added up times the height. Okay, we've had a bunch of that kind of stuff. But this is the area of a regular polygon. Here it is. Everybody ready? It's 1/2 the apothem, right? We talked about what the apothem was. And then I'm going to put a P. What do you think the P is talking about? We haven't mentioned that today, but it's something that you're probably familiar with. And I think it's something that we've talked about before. What do you think that word P represents here? If I go all the way around this whole thing, what am I finding? I'm finding the what? Say it. Perimeter. Very good. So that P represents perimeter. Just right there. Just anywhere. Okay? So the P represents the perimeter. What does the A represent? No, not this little a. This little a right here I'm pointing. See that arrow? What is it? It's the apothem. Okay, and then obviously the capital A represents what? The area. So if you just go the apothem times the perimeter and then divide it by 2, boom, you got the area. It's almost like a triangle, isn't it? And in fact, we're going to make this into a triangle. Well, we're going to make something into a triangle. Let me, oops. Oh, come on. There we go. I'm going to put the center right there. And watch what I'm going to do. I'm going to draw a radius here. I'm going to draw a radius here. First of all, let's talk about this. They tell you the side is 10 centimeters. Okay? So it's a regular octagon. So if that's 10 centimeters, what is it down the bottom of this triangle right here? That's also 10 centimeters. Agreed? Because it's regular. All the sides are equal. Okay? So I want to find the area of this. Well, the perimeter should be very easy. Let's do that. I'll put P equals. You should be able to do that in your head. How many sides do we have? You got 8. No, not 80. How many sides do you have? You got 8. Okay? So what's the perimeter? 8 what? Now you can say it. 8 times 10, which is 80. So I'm going to write that down. 8 times 10 centimeters, and that gives you what? 80 centimeters. By the way, on the quiz, you're just lucky that I'm nice. Some of you. Why? Why am I saying that on the quiz? Nah, that's not why. I do that all the time. On this particular one, I gave you problems that were correct that I should have marked wrong. Why should I have marked a couple of these wrong? Because you didn't put the units on there, okay? Several of you did not put the units on there. And I said for the other quiz, remember that? I would mark it wrong, even if the units are not on there, and they should be, I'm going to mark it wrong. Luckily, I gave it to you because the reason I gave it to you is because I didn't sit there and warn you before I gave you the quiz, make sure you put the units on there. But I shouldn't have to do that. Everybody hear me? Because there may be another time where I don't warn you to make sure you put the units on there, but I'm going to mark it wrong because you didn't put them on there. Here's another thing. Oh, I don't know why you guys do this. I'm not going to point anybody out. You know who you are, okay? But if I ask for the length of something, I don't know, I'm just making this one up. If I ask for the length of something, AB means the length. If I see this again, I'm going to strangle you. This is what some people do. Does that make any sense whatsoever? You tell me. Is that logical? Why not? It's degrees. Degrees is what? For angles. Why are we doing this? We're still doing this. And not just one person. Okay? We're still doing this. Stop it. Stop it. Stop it. Okay? I don't know what else to tell you. If it asks for a line segment, this line segment is not 10 degrees. What's the only thing that are in degrees? Angles. Angles are in degrees. Nothing else. I should mark that wrong. Okay? Even if the number was supposed to be 30. Right? Like right here. This is what some people are doing. All right? 80 degrees. Does that make any sense for the perimeter to be in degrees? No. Stop it. All right. Did I make myself clear? Good. Drives me nuts. All right. What are we trying to do here? We're trying to find the area of this thing. What are we missing? Perimeter. That was easy. 80 centimeters. Half. I know how to do that, right? Half of 80 is 40. We'll do that at the end. But what's the thing I don't know? I don't know the apothem. That's where it can get kind of tricky. All right. Now, I'm going to give you triangles that the apothem works out kind of nice. But sometimes it doesn't work out so nice, and you got to know a lot higher math to figure out the apothem than what we're going to do now. So the ones that I'm going to give you always work out pretty nice. All right. So what I'm going to do is this. Let's write the apothem. I'll even put it in a different color. We'll go red. What is the apothem? It goes from where to where? It goes from the center where? Anywhere to the side? Like that? Is that the apothem? Perpendicular, right. Okay. Perpendicular to the side. It could be any side. I could have gone way up here. But that'd be silly because my little triangle thing is here. I'm going to use that triangle. Make sense? All right. So that is the apothem, and that's what I want to try to find. That's the hardest part about doing these problems is figuring that out. Now, how in the world do we figure it out? Let me Oh, you know what? Oh, my goodness. On this one, I'll just do what they have you do. This is the example, okay? This one, they tell you the apothem. And the next one, you're going to have to find the apothem. On this one, they tell you the apothem. All right, because you would not be able to find the area of this with your level of knowledge right now. You would not be able to find the area of this, okay? That's why we're going to do another one, because you should be able to find the area of the next one we do. But they tell you what the area or what the apothem is, and they tell you it's 12.1. So they make this super easy. It's 12.1 centimeters, all right? Everybody with me? So they give it to you. Really, again, that's the only way that you can find the area of this whole entire thing, is if they give you that apothem, okay? So let's do it. Let's find the area. What's the area equal to? Here's your area right there. It's 1/2. The apothem, what's the apothem? 12.1. Yeah, super easy because they told it to us. And then the perimeter. The perimeter is the only thing we had to do really any work on, isn't it? So what is the perimeter of this thing? It's 80 what? Centimeters. Okay, and now we do the work. Half of 80 is 40. 40 times 12.1 is 484. I'll do the math for you. It's 484. But do we just leave it like that? No. If I'm not in a kind, generous mood, I would mark that wrong if that's how you left it. If I'm in a nice mood, then I might give it to you. But what should it be? It should be 484 what? Centimeters squared. Don't you dare say degrees. All right. So this is area, 484 centimeters squared. It's not that hard when they give you the apothem. Would you agree? Yeah, it's pretty easy. All right. If they give you a side to find the perimeter, it's not that hard. You just multiply how many sides you have by the length of each side, and you've got it. Now, let's do this one. Oh my goodness, I got 5 minutes. All this blabbing I'm doing. I need to shut it and just teach. All right, what's this thing? That's not a stop sign. That's a hexagon. Denise, got it? All right, so what I'm going to do, I'm going to put a center right there, and I'm going to put a couple radii in here. I could go anywhere, right? I mean, I could go to these vertices. I don't know. It's just a lot easier doing this one here on the bottom, okay? And I am going to put an apothem in there. Since I made that red on the other one, I'll make it red on this one. It's perpendicular to that side, yes? And then there's my right angle. And they tell you a few things. Let's see what they tell you. Every regular hexagon. They tell you the side is 4 inches. 4 inches. You can put it anywhere on here. So what's the whole entire bottom of this triangle right here? That's also 4 inches. Agreed? All right. So how do you find the area? The area is 1/2 the apothem times the perimeter. Well, the perimeter is easy. Let's do the perimeter first. Remember, this is a hexagon. How many sides do we have? 6 hexa, 6 sides. 1, 2, 3, 4, 5, 6. Okay, so what's the perimeter? 6 times 4. So what's the perimeter of the whole thing? It's 24 what? Inches. It's not degrees. 24 inches. Okay, so that was easy. They gave you the side. The perimeter super easy. All right, now I got to find the apothem. Now here's the key. I got 2 minutes, so watch very carefully. I'm going to talk fast, okay? What I'm going to do is I want to find out what kind of a triangle I have. Well, by the way, let's do this. See how that comes down right here? Where do you think it hits? Right here. At the midpoint, that's right. So if this whole bottom is 4, what's this little bit from here to here? That's what? It's 2, all right? So I got to find this right here. Well, if I have a special triangle, I might be able to find it, right? If it's either a 45-45-90 or a 30-60-90, I should be able to find that side, right? Well, how do we know what kind of a triangle it is? Let's find the central angle first. So how do I find the central angle? I take 360 divided by what? 6. And what is 360 divided, or sorry, why did I put 4? What is that? That's 60 degrees. So that big yellow angle right there is 60 degrees. But I don't care about the big angle. I want to look at the right triangle. So what's this little skinny angle right there going to be? It's split in half, isn't it? Just like this is split in half. So if the whole thing is 60, that's 30. So if that's 30 and that's 90, what's this one? That's also 60 degrees. Agreed? Look what kind of triangle I have. I got a what? I got a 30, 60, 90 triangle. So what do I know about a 30, 60, 90 triangle? What about the long side and the short side, since we're running out of time? The long side is what? The square root of 3 times the short side. So guess what? What's the long side of this? It's the apothem, isn't it? You see it? So the apothem is equal to 2 times the square root of 3. Almost done. Hang on. We got to put it all together now. So how do I find the area of this thing? It's 1/2. The apothem, what's the apothem? 2 squared of 3 times the perimeter. I found the perimeter earlier. And there you go. Here's how I would do it. What's half of 2? It's just 1. So what's the area? What's a nice way to write this area? Just 24. Always put the number out in front, then the square root. Square root of 3. It's in inches, so what's my units? It's inches what? Squared. All right, and that's how you do it. So you are doing numbers 5 to 12 and 14 to 22. And that's, you can't change anything on it. So it's section 7.5, there you go. All right, you can find the page numbers. Just go to section 7.5. You know where the problems are. Do 5 to 12, 14 to 22. That's due tomorrow. All right, look at that. We got it. I said I didn't mark it wrong, so don't worry about it.